Hello folks, this is Nimitika here. So this is my little info channel and the first video I'm going to talk about is Apache Cassandra. So Apache Cassandra is nothing but a NoSQL database. So I hope you all know about what is database. The database is used to store the huge amount of data and to monitor and to manage them. So Cassandra is a NoSQL database, which means it doesn't have any schemas and doesn't have any structured patterns to store databases. So it can store any type of data like structured, semi-structured or unstructured. So first Cassandra is developed in Facebook to handle the inbox searches, but further, it was given to an open source by Apache Foundation. So let's get dive into it. So first, we can see a definition of Apache Cassandra. So Apache Cassandra is designed to store massive datasets across multiple servers. So many servers are connected together and with a network. So yeah, like distributed databases. So like traditional databases, it doesn't have any point of failures. It ensures there is no single point of failure. So this is the main feature of this Cassandra. So as I said before, it provides a high availability, horizontal scalability, that is you can add as many servers as you can, and flexible schema designs, making it suitable for large scale application. So as I said before, this is mainly used for the large data sets when we're gonna store the huge amount of data. So it is mainly used for managing the time series data, like to time the data may change, the data may flow more, and handling real-time big data applications and supporting high velocity transactions. So we should have the fast transactions, right? So if I send any amount in online transaction, it must go like within a fraction of seconds. So for all these features, Cassandra is mainly used, and it's used in industries like banking, e-commerce and social media platforms. Yeah. And then system architecture. So it has the peer-to-peer architecture, which means it doesn't have a master-slave setup. Cassandra distributes data equally across nodes, so there is no master-slave relationship. Every node has the same responsibility. There is not a main node to take care of all the other slave nodes. And nodes and data centers. So nodes are the individual machines that are individual servers, you can say. So number of nodes are grouped to form a data center. So this structure helps with load balancing and redundancy. So coming to consistency and replication, data is replicated across multiple nodes to ensure the fault tolerance and high availability. So if any one node fails, yes, there is no problem. Another node can take over easily. So there is no way that there could be any data loss or failure. And coming on to the data model, it has three main features. So one is column families. So column families, like instead of traditional databases which we actually store like columns and into a table, right? So here we, instead of storing data like table, individual tables, we store in column families, which allows faster queries by grouping frequently accessed columns together. So we are going to just separate the columns based on their group. If your four columns related to one thing, they're gonna group that separate, and to 4 5 columns they are related to another thing, yeah, they are gonna separate. Like that we're gonna access it. And the second thing is rows and columns. Each row, as we have known, they represent records, and columns to specific data related to that record. So partitions and keys, as I said before, we just divide the data and give it to nodes, right? So here we have the partition keys, which helps balance the load and speed up data retrieval. So this gonna decide in which node which data is gonna be and how data are related with each other. And the next thing is how data are imported into this Cassandra and being transported to any other storage devices. And importing data, we can use the copy command in SQL. So SQL is nothing but the Cassandra query language. It has the separate query language for this. So we can just use a copy command as well as the external connectors like extract, transform, and load processes. And for exporting data, we can use the same copy command, or you can use some custom scripts to transfer it to other storage devices. So moving on to the security part, we have the authentication or authorization and encryption. So nobody can go into this and see all the data. So it's more secure and has the limits and authentications. So only authorized users can access data using a multi-factor authentication for added security. So if I'm developing this, I'm definitely gonna have an authorization for myself. So, and the transactions which is going to happen here are encrypted both in transit and at rest using advanced encryption techniques to prevent unauthorized access. So, our data is going to keep safe more and more. And coming on to the real world applications using Cassandra, it's mainly used in the tech industry and in social medias like Netflix, Facebook, Uber. They all use this Cassandra for real-time analytics, fraud detection, and recommendation engines and IoT data processing. And in financial side, mainly banks and financial institutions rely on Cassandra for secure transaction, large-scale data management, and regulatory compliance, ensuring smooth operations even during peak loads. So as I said before, this Cassandra's main feature is the no fault tolerance. So it's not gonna fail at even at once. So one node fails, no other node can fail. They're gonna run anywhere. So that concludes my presentation on Apache Cassandra. I hope you have known a little things about Cassandra now. So if you wanna know more about this, let me know. And thank you for your time.